All right, sorry about that. We'll give everybody a time to get back on here. I lost my connection there for a second, so we'll do this in two parts, and then I'll splice it together for YouTube, and that way there'll be a little bit of a complete single video for YouTube. So I guess that's one of the foibles about doing this live. So anyway, I'll post both of these in Science Freedom Florida. Obviously, they're both going to be here on my page. So give you guys a couple of seconds to get back on. All right, so I'm going to kind of start back over where I was in the actual page. It says, when you read about cells and genetics, you will see that all organisms have similar cell structures and chemical processes. These shared characteristics result from a common evolutionary descent. There it is. Both human and bacterial genetics are based on the same molecules, DNA and RNA. So it's just right there. These shared characteristics result from a common evolutionary descent. There is no hesitation. There's no ambiguity. There's nothing about theory here. The way that they're stating it, there's no theory at all. That word theory, as we've talked about many times, that the word theory is just kind of an idea that's been around for a while. It's got some people have tried to put stuff behind it, maybe some testing behind it, or maybe there's some. You might think of somebody that's got some experience behind them because they've been around for a while. So there's nothing in this language that has any kind of theory. They talk about it as if it's fact. And this goes back to David Campbell's speech during the February board meeting, where he said it's fact. It's fact. That he just said it over and over again in his little 10-minute speech, that there's no questioning of it. That's how they believe it. That's how they teach it, and that's how the textbook is teaching it. And we were told that that's not the case. That we were told flat out at that board meeting by those who supported the textbook that it was just going to be taught as a theory. And here it is, fact, fact, fact. That's just how they shove it in their little minds over and over again. But this isn't a necessary conclusion, and I'm going to tell you why. First of all, there are 118 elements on the periodic table. 92 of those are found in nature. Only 5 are used as the building blocks of DNA and RNA. So only 5. Welcome back, Jeremy. Welcome to both of the Gilhausens. Ashley and Adam are on board with us, so glad to see you guys here. But out of those 5, we've got carbon, hydrogen, oxygen, nitrogen, and phosphorus. That's it. And there's only so many ways that those can be arranged. And when you have that kind of limitation as the building block for all of life, you have to realize that there's going to be some similarities. Why do we drive cars on wheels? Why is there wheels on the vast majority of our vehicles? Why don't we have legs? Why don't we have skis? Why don't we have treads? I mean, some of our vehicles have treads. Why don't all our vehicles have treads? And the answer is that the environment led us to design our vehicles the way that they are, with wheels. And so when we look at the environment that we have for living organisms and the limitation that we have on the chemicals, it's not a wonder, it's not a surprise to anybody that we're going to find similarities. What those similarities don't demand is that we all came from the same organism millions of years ago. That is a step too far. Okay, it's literally a bridge to nowhere, to go back to an old political problem. So that conclusion is not demanded. Common descent is not demanded. It's like saying let's see, an analogy would be why we only build spacecraft out of certain materials and not others. Only certain materials are useful for the purpose at hand. The building blocks of life are what they are because only those exact chemicals are good for that purpose. A lot of you who know me know that I write science fiction and fantasy. And one of the big staples of science fiction is coming up with organisms that are not carbon-based. Very few things. That's right, Jeremy. But that organism's not carbon-based, they're silicon-based. And we toy with this idea, but there's some problems with that. Silicon has some major flaws that don't make it good, even though it has the same electron configuration. Silicon is not good for living organisms. It's a bigger atom, for one thing. The electrons are farther away from the nucleus. And there's a lot of other problems that come along with it. I'm not going to bore you with all the technicalities, but, it's science fiction because it doesn't work. Like giant mecha fighting, the Pacific Rim movies. I enjoyed those. I'm easy to please, I guess. Those are fun movies. Those mecha can't be built. Those are physically impossible to build. As fun as they are to think about, as fun as the fiction was, those mecha cannot be built because of the laws of physics. In the same way, we have limitations on the chemicals that make up life. And so, of course, we're going to see some similarities. That does not prove that they all came from the same organism. When we read through the textbook, when we're looking at the biology textbook, one of the things that you will note, if you're paying attention, if you're ready to understand what the textbook does, hey Joe, welcome aboard, is that they start with their conclusion. They assume the truth of evolution, and then everything that they present is based on that conclusion. It's like starting with the end of a book and then writing the book to fit that conclusion. Now, as a book writer, I know that there's authors that do that, and that's great. But that's fiction. Just like evolution is fiction. They started with their conclusion, and they're going to interpret all the data to match that because they want it to be true, but they don't actually have the evidence to make it true. But here in the textbook, they're presenting it as true, and that's why we're examining this. All right, so it says the same chemical reality holds true for comparing humans and bacteria cells. This is what I wrote in my article when I was preparing for this. When comparing humans and bacteria cells across species and energy storage, one of the very few laws of biology is that biology has to obey all the laws of chemistry. Given the limited amount of chemicals, their unique structures, and the limited ways they bond together, there's only so many ways that chemicals can store energy within a common environment, can defend the cell in that common environment. This does not demand common descent as an explanation for why they are the same. That's just an assertion. Where's the evidence? Common environment and common chemical properties alone are not sufficient for the conclusion. There has to be some kind of a historical record, such as the chain of descent. And guys, that's going to get into the Tressa McCabe. Man, it's good to see you here. One of the people that inspired me to become a teacher was my old English teacher from the was it 10th grade? I believe it was 10th grade, if I remember correctly. Yeah, it was 10th grade. So welcome aboard. Glad to have you here. Anyway, one of the things that they try to show is that, well, you're looking for historical record. Well, that's the fossil record. And we're going to examine that in detail when the book gets to it. But the short version of it is the evolutionists try to say that the fossil record is a historical record of descent. But fossils, they can't tell us if an animal reproduced. So we find a fossil in the ground, we dig it up. Do we even know that particular fossil had a kid? We don't know that. There's no way to tell. So to say that this is somehow part of the evolutionary chain, it's just not. You can't make that assumption. And so we don't know that that's part of. Hey, Brian, we don't know that that's part of the evolutionary chain that they're asserting. If we grant that evolution is even true, just by digging up a fossil, and we'll talk more about that when we get to those in the textbook. So. All they've done on this page really is done the very thing said the very thing that the textbook is not supposed to say. And that is that evolution is true. They've made the assertion, they've stated it as true several times in here, and they never in the book are going to present actual evidence that demands the conclusion that evolution is true. They're going to say it over and over again. They're going to say evolution is true, evolution is true. And they're going to say, see here, we're going to look at these whale bones, or we're going to look at these fossil records here, or we're going to talk about radiocarbon dating, or we're going to talk about all of these things. And we know evolution is true, and so these things prove evolution is true. And not a single one of them are. And I've got over 100 pages to go through, so this is probably going to take me a while. I don't know that I'm going to be here every night, but I'm going to try to be here a lot, especially during this month because of the election. We got 8 days until election day, so I'm probably going to get through 8 more pages by then. I'll be done, I think, with the introduction by tomorrow of the textbook in chapter 1, and we'll skip over to chapter 10 where they really get their gears revved up on this evolution stuff. So again, I really appreciate you guys watching. Really would appreciate it if you guys would share this stuff. Yes, Adam, the grade the grade that the textbook is used in is high school, and typically those are younger students. So coming out of junior high, where they've already been partially indoctrinated in 7th and 8th grade, they're going to come out in 9th grade and take biology. Sometimes it might be 10th grade, but it's usually the younger students. And I've actually talked to several people about this, not necessarily from an anti-evolutionary perspective, but just so that the students have a better grasp of things. I'm actually a physics first kind of guy. I think freshmen can come out of junior high and learn physics. All they need is to be taking Algebra 1 at the same time, and they can take the conceptual physics just fine as freshmen, and then I think they should take chemistry after that because physics naturally flows into it. You get to the end of physics and you're talking nuclear physics, well, that's the atom, that's the nucleus, the protons, the neutrons, the electrons and stuff. Well, guess what you start with in chemistry? The same thing. And then chemistry goes all the way around. Hold on, we're trying to reconnect. Okay, there we are. Anyway, we get around to chemistry and organic chemistry. Well, that leads right into biology, and then you can have a real conversation about biology in terms of the physics and chemistry that biology is built on. But we don't do it that way. The public schools are structured so that we teach biology first, while the kids are still more impressionable and less independent, and so we can shove evolution down their throats when they still aren't knowledgeable enough and mature enough to defend themselves, unless you get somebody that just has great parents, for one thing, like I did, or you have somebody who's just as stubborn as all get out, and I guess that's me too. So, but yeah, they start the textbook as freshmen and whatnot. So, hello, Luke. Welcome aboard. Will I be reviewing the middle school textbooks as well? You know what? If I could get a hold of them, I would certainly love to. I think that falls right in line with what Science Freedom Florida is all about. There's a lot of apologetic stuff out there that is geared towards the religious side of things. I'm really trying to keep this just geared towards the science side of things. Although in comments and in conversations in the threads and stuff, I'll happily talk religion for whoever wants to ask that. But as far as the video is concerned, I'm keeping this just science. So if I could get hold of the middle school textbooks, I will go through them with a fine-tooth comb, just like I'm doing the current biology textbook. And I got to tell you, the conceptual textbook that I was using at my last job at Clay High, that the district uses now, that's the book I started with back in Texas, and I really like the book. And they do have, from time to time, mentions of millions of years and that kind of nonsense, and they do talk about radiometric dating in one of the chapters, but it's so much more practical, and it really doesn't try to go overboard with the whole in-your-face evolution thing. The physics textbook doesn't really I wish they didn't have it at all, of course, but it's not in your face like the biology textbooks are. The biology textbooks, that's their goal. You know, they teach that other stuff, biomes and just the when you get into the living habits, the environment, and what they eat, and where they sleep, and how the animals interrelate to each other, the food web, and all that stuff. They have those things, and those parts are good, but the biology textbook is relentless in pushing evolution because, we just read evolution is the unifying theme of biology. That's what they believe. So, but yeah, if somebody can get me a copy of those, maybe some junior high kid somewhere that I know personally will let me borrow that or something, then we can do that. You would like more info on carbon dating? Well, I'll give you a quick rundown of it here, and then maybe something a little bit more in depth when we get into the dating. Carbon dating, if anybody tells you that they carbon dated like a dinosaur bone, yes, my wife is going to make fun of me for saying dinosaur. It's not a dino boo-boo. But anyway, if they say we dated dinosaur bones to be millions of years old, well, no, it's not really. So carbon dating, and it's got to be specifically carbon, only works up to about 60,000 years. The half-life of carbon is only roughly 5,700 years, 6,000 years if you want to really round it up to a single digit kind of thing there. But you get up to 60,000 years, and what happens is you reach a level of radioactivity inside of a living organism that will kill it. And so you can't have too much of the radioactive carbon in it. And then if you go the other direction, it starts getting to be so small after that 60,000 years that we don't have technology that can detect it. And so there's an upper limit to the amount of carbon dating. Yes, thank you. Okay, Madison. You and my wife are conspiring, I think. But anyway, that's the carbon dating in a nutshell. Is you can't have carbon dating anything over what's essentially modern human history. Welcome back, Lisa. Sorry about getting disconnected. So when we get into the full radiometric dating, that's a little bit longer conversation, but there are a number of assumptions that are made about the radiometric dating that they have to have true. These assumptions must be true, and in the cases of most of them, they can't know what they need to know. It's impossible to know. It's logically impossible for them to know what they need to know. And in the other cases, we actually know that it's not true. One of those is the assumption that the radiometric decay rates, the decay rates of the radioactive material is relatively constant. They believe that it's relatively constant, that no physical process can change that, and we know for a fact that that's not true. So there's a lot there. It's not as complicated as what a lot of people make it out to be. Hey, Savannah, welcome aboard. This is the second half. The first half got cut off because of my connection. So be sure and go back and watch that part. But Adam, as far as all the radiometric dating goes, don't let them convince you that it's actually too complicated for most people to understand. I explained it to my physics classes for 11 years, and they got it. It was super easy to understand. You just have to trust that your kids or that your students are able to handle it, and just throw it out there. And we've had some really good discussion. So thanks. Any other questions before I head out for the night? All right, folks. Well, again, I appreciate you being here, and please just share the heck out of this thing, and especially right now during the election cycle for the school board, please get out and vote. The people that really need your support, LaTanya Peterson and Ashley Gilhausen and Betsy Condon, those three ladies are really going to support sound science. They're ones that are going to support the challenge that the students need to bring in the science classroom. They're the ones that are for actually teaching science in the science classroom, even if it happens to contradict a beloved pet theory, or in my, as I call it, a hypothesis with a superego, which is all evolution really is. Evolution is not in my book, it's not a theory because it doesn't have any supporting data. It's just a hyperinflated hypothesis. So let's see here. Jeremy asks, to what extent have people tested and established alterations in decay rates? that is a very extended question, Jeremy, and I don't want to answer that question without looking into it and giving you specifics, because my memory for stuff like that is not 100%, and I don't want to say it wrong. You know what I'm saying? So I see your comment, and other people see your comment, and I will get that data, and I will post it as a reply, and anybody who wants to see it can see that. I know that there have been a lot of people who have done those experiments and shown that the decay rates are there. I know they've done some stuff with the halos around the helium atoms. I know that they've done the zircon. I know that the helium that remains in the ground, which is part of that alpha decay, the helium that's there is too much to account for millions of years, and so we know that the decay rates can change. So yeah, there's a lot of data out there that shows that the decay rates do in fact change. In fact, we can give evidence in terms of a lot of examples. The Velocevich mammoth, which was carbon dated at something like 27,000 years at one end, and then something like 44,000 years old at the other end. It was the same mammoth, but they dated both the head and the butt several thousand years apart. They dated live organisms at being 1,000 years dead and stuff like that. So there's all kinds of examples that we could give where the dating methods just aren't correct. But there's also examples we can give, testing that's been done to show that the radioactive rates actually change, that they speed up, and that makes things look older than they actually are. So anyway, guys, get out and vote. Thank you so much for tuning in. And like I said, share this all over the place, and ask your questions in the comments. I'll post up some stuff in the comments, including the snapshot of the textbook that I have, and y'all keep learning. Y'all have a good night.